Okay, so we're going to pick up in the middle of section 5.3, part 2, looking at problems that have the box in the template. When the box is there for you, if you see it on the test, it probably means that it's a problem where you need to use it. If you see a template without boxes, that's kind of a hint that it's the case we did on Monday, and you don't have to multiply by anything first. All right, so I'm going to give you guys maybe a couple minutes to try that. See, see if you already have same number, same letter, opposite sign. If you do, then that's what we learned on Monday, and you can just add them up. If you don't, but you have two positive variables that are the same in the same column, then you need to multiply by a -1 first. Okay, so take a couple of minutes. We'll walk around and check in with you guys. Okay, so let's start to take a look at it. And remember, first thing you want to look at is, do you have same letter, same number, opposite signs? If you do, you're ready to add right away. Do we have same letter, same number, opposite signs? Okay? No. So you can't add these right away because nothing will cancel out. But we do have a same positive single variable in both equations. That's like an x and an x, or a y and a y. What variable do we have here that's all by itself and positive in both equations? Yep, the x. So the directions say when you have a single positive variable in both of the equations, multiply by -1. It doesn't matter which equation you multiply by -1. So Caleb, which one do you want to do? Oh, that's right, you just got that. So which equation do we want to multiply by -1?
The first one?
The first one, okay. So let's put -1 down. And then x minus 3y equals 18. Okay, I'm checking it as I go. X's, y's, numbers, everything looks good. Okay. X's, y's, numbers. What's going to go in the second box? Yeah? Nothing. Yep, you don't need it. Are you going to need it? Yeah, sometimes you're going to need both boxes. Not today, but you'll need both tomorrow. Okay, so the second equation is not changing. So let's copy that one down. X plus 5y equals 2. And what am I multiplying everything in the top equation by? Yeah.
-1.
Good. -1. So, Annika, can you tell me what I'll get when I multiply every number in the top equation by -1? Yep. So can you read to me like what I would put down right here? So we got -x. Yep. Yeah, so what's -3y times -1? That's a positive 3y. And then -18. Okay, so now if we did that first step right, you should have same letter, same number, different signs, and something should cancel out. Let's see. Michael, what do I get when I add up those first two, that first column? They cancel out. Those are gone. Michael, how about when I add up my second column? 8y. And Alyssa, when I add up my third column? Perfect. -16. Okay, so the x is eliminated. You don't have, that's what this little thing here is to fill in. So don't worry. We multiplied the top equation and we eliminated the x's. You don't have to fill that in. But that's what we did. All right, Anaya, what's my last step here to get y by itself?
Divide by 8 on both sides.
Yep. And what does that give me?
-2.
Good, -2. Okay, so we've got y. Caleb, what do I still need to find?
So like find x.
And how do I do it?
You plug in -2 into one of the two problems.
Yep, and which one do you want to plug back into?
Top one.
Top one? Okay, so we're going to take -2. And remember, you're filling it back in for y. I saw some people put it back in for x. That won't work. You have to put it back in for the y, whatever letter you solve for. Alright, so we've got x minus 3, and then next to the 3, put -2. Okay, Abby, what's the first thing I would do there?
Distribute -3 plus 8. Yeah, like distribute.
Yeah, we just multiply,
Yeah.
because really it's just one thing that we're going to multiply to. What do you get when you do that?
-6. Or no,
+6. So that's x plus 6 equals 18. And Emily, my last step? Subtract 6 from both sides. Very good. And what does that give me for x? 12. Okay. Any questions on that one? Okay, so the whole goal is to end up with same letter, same number, opposite signs. That's what you want to have every time. Sometimes you have it right away. That's what we did on Monday. Sometimes you don't. And you have to do something to fix it so you do. So now, let's look at situation. Well, don't write it down yet, because I got to give you the notes on how to do situation 3. But this is the one we're going to do. Now, let's see if it's situation 1 or 2. Do I have the same letter with the same number and opposite signs right away? No. I don't have the same letter, same number, opposite signs. So it's not situation 1. Situation 2. Do I have a positive single variable in both equations? Aiden? No. To have a positive single variable in both equations, I would need like a positive x and a positive x, or a positive y and a positive y. Well, this is an x, that's a 2x. No, that has a 2. That's a y, that's a 7y. So this is not situation 1 or 2. This is going to be situation 3. In situation 3, we need to make it so that when we add up one of these columns, the letter cancels out. Look at this top one. What would you have to have right here so that if you added it to what's below it, they would cancel out? Magically, if you could make this anything you wanted, what could you make it so that it cancels out what's below it? Yep. You could make it a -2x. If you can figure out how to make this a -2x, that's one way to do this problem. Or, look at this one. If you could magically make that anything you want, what could you make it so that it would cancel out 7y? Yep. -7y. You have to make one of those two things happen. You can't do both, but you have to pick one. So either somehow we're going to make this a -2x, or somehow we're going to have to make that a -7y. You have to. That's the only way elimination is going to work. And that's situation 3. All right, so at the top of your guided notes, you guys have a spot for writing down situation 3. In situation 3, is when you have a single variable, but it's only in one of the equations. It's not in both. If it's in both, then we can do it like situation 2. But if it's only in one of them, it's a little different. Here's an example of a situation 3 problem. I have a single positive variable, but it's only in one of the equations. Yeah. Yeah. It's not in both. So what are we going to do? I'm going to highlight what you're going to focus on. I'm going to focus on what I just highlighted. And you're going to multiply the equation that has the single variable, which in this case is the bottom. You're going to multiply the equation with the single variable by the opposite of the number that's attached to that variable in the top equation. And the reason why we're going to do that is because you've got a 5x and you've got an x. What cancels out positive 5x? Yeah?
Negative 5x.
Negative 5x. The only way you could make this a negative 5x is if you multiply every number in the bottom by the opposite of 5, which is negative 5. So we multiply every number in the bottom by negative 5, and that's going to make this a negative 5x. It's going to make these other numbers something different too, but the point is I'll have a 5x and a negative 5x, and then they'll cancel. So multiply the equation that has the single variable by the opposite of the number attached to that variable in the top equation. Again, this is situation 3. Okay, does everybody have the what to do box copied down? Okay, so there's still a situation 4 and 5, but those are going to save for the guided notes tomorrow. All right, so let's try this one. So what I do is I go through those situations in order. Do we have the same letter, same number, opposite sign? What do you think, Dorian?
No.
No. That'd be the easiest case. That's like when you have a 2x and a negative 2x, or a 3y and a negative 3y. We don't have, so it's not situation 1. Do we have a variable that doesn't have a number next to it in both equations? Okay. No. Okay, that would be situation 2, like a positive x and a positive x. We don't have that. Do we have an equation that has one variable by itself with no number next to it? Just a
Yeah.
Which equation? The top one. In fact, we have 2 variables that don't have any numbers next to them. So we're going to pick. Finn, what variable do you want to try to eliminate?
The X.
The x. Okay. So then the bottom equation stays the same. You're not going to multiply that one by anything. So 2x plus 7y equals 9. So we're not using that. But the top one, we're going to have to multiply by something. Let's write it down. And now, I need to know what goes in this box. What could I multiply this top equation by so that we could make the x's eliminate? Why the x's? Because that's what finish. Yep. Yeah. Multiply everything in this equation by the opposite of the number that's attached to x right here, -2. And then watch what that does. Let's do it out. So, Abby, what's -2 times x? So we get -2x, and we gotta do it to all of them. Lexi, what's -2 times y? So -2y. And on the other side, Tirza, what's -2 times 2? -4. So there's the top equation with everything multiplied by -2. What am I multiplying the bottom equation by? Yeah, nothing. That one stays the same. Are we going to have to multiply both equations by a number eventually? Yes. But for today, it's just one or the other. So now we have 2x plus 7y equals 9. And if you multiplied by something that was correct, you should have a column that now cancels out. If you add these up and nothing cancels out, then you didn't pick the right number to put in that box. Okay, let's see what happens. Joe, when I add the first column up, what do I get? So pretend like the x's weren't there. What if you just had that? -2 plus 2. -4 it cancels out. Right? -2 plus 2 is 0. So that's gone. How about my second column? What do we get when we add up the y column? Yep. 5y. So that's 5y. And how about when I add up the right-hand column? Yeah, 5. So you're going to notice most of these don't come out to messy answers with fractions. I'm not saying you'll never get a fraction, but most of the time, there's problems that come up with these. Okay. Sean, what's my last step to get y? Divide by 5. And what does that give me for y? 1. Perfect. Okay, so now we've got y. Now we have to go back and get x. I mean, we can put x in this box right now if we want. We got to figure out what it is. Okay, how do I get x? Yep.
You would have to use one of the equations.
Yep, we're going to use one of the equations, and what are we going to fill into it?
You would fill in the y, or you got the y.
And what are you filling in?
You're going to fill in the 1 for y.
And which one? I think this time there's definitely an equation to me that looks easier.
I think equation 1.
Yeah, equation 1, a lot easier. Numbers are much smaller. So take the 1 and plug the 1 back in for the y, now that you know what it is. So x plus 1 equals 2. And last step to get x by itself. Yeah. Perfect. Subtract 1 from both sides. So we end up with x equals 1. Yeah, just a coincidence that x and y came out the same, and usually they don't. But they can. That's okay. Any question on that's situation 3? Yeah. You mean use this one? Well, as long as you multiply everything by the same number, using this equation or this equation would have given you the same answer. I went back to the original problem because I like the numbers that were small. That's why I use that. So I always go back to one of these two originals. Yep. Yes. Okay. Any other questions on that? So even if you forget what situation it is, I just kind of did that to help you guys organize it. Remember the goal. Same letter, same number, opposite sign. If you can make that happen, doesn't matter what situation it is. That's the whole goal. Okay. All right, let's try. All right, that was 2A. Do you guys have a spot on your notes for 2B? Okay, let's do 2B. I'm going to start you off doing a little bit of it together, and then I'm going to let you guys try it. Now, I kind of gave you a hint here. Something's wrong with the setup in this problem. What is wrong with the setup? This is a thing you have to check no matter what kind of problem you're doing. Yep.
Sorry, the X is on the wrong side.
Right, X is on the wrong side. You always want X's, Y's, and numbers. Is there an equation there that's already set up like that? X's, Y's, and then numbers. What is that? The bottom one. So you can go ahead and write that one down. That one's fine. But do not put anything on that equation 1 line until you fix equation 1 to be in the right pattern. So let's just bring this over here. That's equation 1. Who can tell me what I have to do to it to fix it so that it's in the right pattern? Yeah. Add 4x and add 4x. So we're going to get 4x minus y equals 7. Okay, let's go through the situations and see which one it is. Do we have, now look at equations 1 and 2. Do we have same letter, same number, opposite signs? Michael?
Yes.
Okay, which column has the same letter, same number, and opposite signs?
On to the lines.
Okay, so same letter, y and y. What number is in front of the y up here?
Negative 1.
-1. And what number is in front of the y down here? Is that the same number? No. So we don't have same letter, same number, opposite signs. Do we have a single positive variable in both of them? No. Positive variable means you're looking for like an x and an x, or a y and a y. So no. Do we have a single variable in at least one of the equations? What do you think? Do we have a single variable in one of the equations? Abby? Yeah, which variable is the single variable in one of the equations? The top, and which variable are you looking at? The negative y, right here. So that's a variable that's by itself in the top. So that's the equation we're going to focus on. So you don't have to worry about the bottom. Focus on the equation that has the single variable on the top. We want to make these two things cancel out. This is a 3y. What would this top have to be to cancel out the one that's in the bottom? Yep. It would have to be a negative 3y. So can you tell me, Aiden, what would I put in this box so when I distribute it out, this is a negative 3y? 3. Yep. I'm going to put a 3 in that box. And now, multiply the 3 out. And the worst thing that can happen is you made a mistake and nothing cancels. Well, if nothing cancels, you pick the wrong number to put in this box. Go back and try a different number. Okay, so the bottom one stays the same. And let's multiply everything in the top equation by 3. Okay, can anyone tell me when you distribute a 3 to it, what happens to the 4x? That becomes 12x. Okay, so the x's definitely don't cancel out. 12x and 5x, that doesn't cancel. So we're hoping the y's cancel. Maya, what about the next one?
Sorry, where?
My next term right in the top equation.
Sorry, I have no idea what you're talking about.
So I'm trying to figure out what this top equation is going to be. After we multiply.
3y. Negative 3y.
Negative 3y, right? Because it's 3 times negative y. And what about the number on the other side? 21. Okay, let's add them up and see if we pick the right number to multiply by. Sophie, what's 12x and 5x? So that's 17x. Just so know, what's negative 3y and positive 3y? There we go. So we picked the right number. We just canceled out the y's. So always focus on the single variable and think, what would you have to change it to make it the opposite of that? Okay, so we've got, that's gone. And what about 21 plus 13? Yeah, 34. Okay, and it looks like some kind of big numbers, but I still think we're going to get a nice answer here. What do we do on both sides to get x alone? Yep.
Divide.
Yep, and what do you divide by?
17.
17. Those cancel, and 34 divided by 17, that does come out to a nice number. Yep, 2. Perfect. So x equals 2. All right, now, I still have to find what? Yep. Still have to find y. And Michael, what equation do you want to use to find it?
Top equation.
Top equation. We're going to use equation 1. So take the 2 and fill the 2 back in for x. How about, Dorian, when I fill the 2 back in, can you just tell me what my equation is going to look like before I do anything else?
Okay. It'd be 4 parentheses 2.
Yep.
Minus y.
Yep.
Equals 7.
Equals 7. Now, if you're wondering, 'cause we had this question before, why didn't I use the one that I multiplied by 3? Well, I could, but all the numbers are 3 times as big there. If I use the original equation, I'm going to get the same answer, and the work is going to be easier for me. That's why I always go back to the original. And it didn't matter which one you use. Okay, so let's do that up. 4 times 2 is 8. So we have 8 minus y equals 7. How about, yeah, 8? Well, if we add 8, we're going to get a 16 here, and we're going to get a 15 here. We want to subtract 8 because we want something to become 0. And now 8 minus 8 is 0. That gives me negative y. And 7 minus 8 is negative 1. So if negative y is negative 1, what's positive y? So right now this is the opposite of the answer that I want because it's negative y. Well, positive y, yeah? 1. There you So the homework tonight, some of you already did the first question. Just finish worksheet 5.3 part 2.